welcome. Today we're looking at functions, and in particular we're going to look at the hyperbolic, the exponential function, and then how the inverse takes part of the section. Now inverses, remember, can be for any graph, but once you have the principle of how they work, it doesn't matter which one you start with. So let's have a look and see what the first question is about. So as I said to you, that's what we're dealing with. This is adapted from November 2011, paper 1, question 5. It says, consider the function f of x equals minus 6 over x minus 3 minus 1. Calculate the coordinates of the y-intercept. Now, it doesn't matter what graph we've got. If we are finding a y-intercept, there's only one way to do it, and that's to let x equal 0. So we're going to do that. So for the y-intercept, let x equal 0. And we're going to go to this equation, if I can get the page to extend. Remember, it reads y equals minus 6 over x minus 3 minus 1. And we're going to let x equal 0, so y is equal to minus 6 over 0 minus 3 minus 1, which means we have minus 6 over minus 3 minus 1. A minus over a minus is a positive, so 6 over 3 gives me 2 minus 1, which is 1. So the y is equal to 1, so we have x is 0, y is 1. Now, why did I do that? Well, the question said to me, find the coordinates. So if they ask you for the coordinates and you just write y equals 1, you haven't answered the question. The question's worth 2 marks. You don't want to lose 1 mark because you forgot to read the instruction. So things like that, it's best to highlight them and to remind yourself. So right, we have that. Notice I haven't even thought about what kind of graph this is yet. That will come later. Right, let's move to the next part of the question. So we found the y-intercept to be 0, 1. Right, this one says, still using the same function, calculate the coordinates of the x-intercept. Once more, coordinates. So for the x-intercept, we let y equal 0. So we go to the equation. If y is equal to 0, oh gosh, I keep doing this, sorry about that. 0 is equal to minus 6 over x minus 3 minus 1. Now, to solve for this, it's up to you how you like to do it. I would bring this to this side, so it becomes 6 over x minus 3 equals minus 1. It doesn't matter if you did it the other way. And now what I would have to do is I'd have to multiply this by x minus 3. And what I do to one side of the equation, I must do the other side. So I times by x minus 3 there. That divides into their ones. So we have 6 equals, and I'm going to multiply the minus 1 in here, minus x plus 3. Remember, we're trying to solve for x, so I'm going to transpose the x over here. And that's going to be 3 minus 6. Right, so 3 minus 6 gives me minus 3. And remember, the question was the coordinate. So we go minus 3, 0. Because we know that the y was 0, the x was minus 3. So far, we haven't even worried about what kind of graph all this is. We had to find an x and y-intercept, and there's no difference between the graphs how we go about that. So right, in the light of that, we're going to take those facts across, 0, 1, and minus 3, 0. So it is 0, 1, and minus 3, 0. I always like to carry the question down so that it's easy for me to refer to it. I don't have to go reworking out anything. Now it says, sketch the graph of f below, showing clearly the asymptotes and the intercepts with the axes. Well, here are our intercepts. We've got those. So what we have to do now is worry about the asymptote. Now, the fact that they've mentioned asymptote, it means it would not be a parabola because parabolas don't have asymptotes. It won't be a straight line because they don't have asymptotes either. It could be a hyperbola and it could be an exponential function. Now, let's look at the value, the way it's written. It's written in this format, which is definitely the format of a hyperbola. Right, so what does that mean? Let's think about it. If it's a hyperbola, how many asymptotes will we have? Well, think about the actual general shape of a hyperbola. If it was just a normal old hyperbola, say y equals 6 over x, it would look like that. Or if it was negative, it would be in the other quadrants, but it would still look like that. And do you agree with me that if we look here, we would have an asymptote that is vertical and an asymptote that is horizontal? So in that light, we can go over here and we can say we must have two asymptotes. Now, there are two ways of handling this, and perhaps the safest way is just to know that to get the one asymptote, you take the denominator equal to 0. So it would be x equals p, and the other one will be this number out here, which is y equals q. So if I go to this here, we have y equals minus 6 over x minus 3 minus 1. So the one asymptote will be x equals 3, and the other one will be y equals minus 1. Now, what has this got to do with it? Well, that decides where it would have been quadrant-wise initially. So as I said to you, this would have been the positive one. The negative one would have been there and there. So what this graph has done is it's shifted left or right, up or down, because it's got a horizontal shift and a vertical shift. So one way to think about it is, we know that x equals 3, so that means this graph has moved 3 units to the right. And we know it's minus 1, so it's shifted 1 unit down. So we already know in the light of that, that this has moved 3 units this way, so that would have been the 3 units this way, and then it's moved 1 unit down. Now if it's moved 1 unit down, in all likelihood it's doing this kind of thing, which we'll do in a moment. Now why have I done that? I've actually thought about how this graph has moved, so that when I start to draw it, I know if I'm right or wrong. So let's have a look at what we know. First thing we know is we have an asymptote at minus 3. Just by the way, a very good idea, in fact an excellent idea, is to actually mark your axes. You must show the x and y and the origin. So the first thing I know is I have an asymptote at x equals 3. So there it is. Let's put it in. And they said marking clearly, so I'm going to put the 3 there so they can see it. And y equals minus 1, here it is. So I'm going to have an asymptote here. So in effect, this becomes my new axis. Right, now we still have two other things we can put in. We've got the x and the y-intercept. The y-intercept was at 0, 1, so it's there. And the x-intercept was at minus 3, which is there. Okay, now what's a bit off-putting is the fact that it's all within this quadrant, but it doesn't matter. Now we know it's hyperbolic, so we know it looks like that. And we know that this point would mirror over here. Now what you could do if you wanted to is you could maybe find 1 or 2 points on that side if you were concerned. But the important thing is you have shown them as they've asked you to. You've shown them your intercepts and your axes. So they're going to be happy with that. That's what they wanted. Okay, let's see what they ask next. Now they say for what values of x is f of x greater than 0? Now I'm going to go back to the drawing first, and we're going to look at this drawing and work it out. You know that this orange thing is the f of x. They want to know when is it greater than 0. So let's get yellow so we can stand up here. Do you agree with me that the f of x is actually the y? So they're saying when is y greater than 0? Now if we think of an axis, y greater than 0 is above the x-axis, equal to 0 is on the x-axis, and less than 0 is underneath the x-axis. So if I go to my drawing, this is where f of x is greater than 0, f of x equals 0, and f of x is less than 0. So they want to know when is it greater than 0. Now it's greater than 0 over here, where I've highlighted in yellow, because that is where it's above. We don't include this point though, because that's where it's equal to 0, and they don't ask that. So if they want me to just read it off the graph, it's a relatively easy question, because all I would do is I would say it's where x is greater than minus 3. Or you can use the notation minus 3 to plus infinity, x an element. Probably you would use this notation though. But let's go to the question and think how else we could do it. It's only 2 marks. It didn't say from your graph determine. So you could do it algebraically, and that's why I say there are 2 ways you can go about it. So let's talk about algebraically. Okay, algebraically, we would look at this and we'd say minus 6 over x minus 3 minus 1 is greater than 0. So that means that minus 6, in fact, we need to make it a common denominator of x minus 3. So that would happen, minus 1 times x minus 3 is greater than 0. So minus 6 minus x plus 3 over x minus 3 is greater than 0. So that becomes minus 3 minus x over x minus 3 greater than 0. Now, what you would have to do at this stage is you'd have to do your critical values or table of sign or a number line. Now, this is not in your syllabus, so I'm pretty sure this question intended for you to use your graph. I will do it the other way just again, so you're going to get two critical values. The critical values come from putting each of your factors equal to 0. So if we do that, we're going to get minus 3 equals x, and over here x equals 3. Okay, and then you would go along and you'd establish a number line. Okay, we know that that's where our asymptote is, so it makes sense that it's part of it. And we know at this point it would be undefined, because if I put in 0 there, the denominator being 0, this one would be 0. And now we would test a value this side. So if we test minus 4, minus 3 minus minus 4 would be a positive. And minus 4 would be a negative. A positive over a negative is a negative. Between these two values, let's take minus 1. Minus 3 minus minus 1 would be a negative. And minus 1 was another negative, so this would be a positive. Over here, if we take, say, 4, minus 3 minus 4 would be a negative. And 4 minus 3 would be a positive. So that would be overall a negative. But we want greater than 0, so we want the positives, so it would be there. So it would be from minus 3 to 3. Okay, not inclusive x. Or you could write it like this. And in fact, this has given me reason to go back to the drawing we had just now, because I did forget something very important. Let's just go back to our drawing. Of course, it's here, but it stops there. So that's where I made a little bit of a mistake here. This should have been 2, 3. And this would have been that other notation I used just now, where x lies between minus 3 and 3. So why is that? Because the asymptote stops the graph in that direction and starts it down here. So that's how I would do it if I did it algebraically, and it just shows you algebraically I was more accurate than I was on the graph version. So just to recap so you're not confused, if I had my graph, here it is, this is how it kind of looked, and over here it was down here. I want to know, where is it greater than 0? Greater than 0 would be from here upwards. Okay, but the x values would have started at minus 3 and they would have ended at 3. So that's how it makes sense now. So algebraically, it actually did me a favor. Right, now let's see what the next question asks. The next question says, consider the function calculate the average gradient of f between minus 2 and 0. Let's go back to our little sketch. They want the average gradient between minus 2 and 0. So they want it from this point to this point. So what they're doing is they're asking you for the gradient of a line that passes through those 2 points. Okay, so right, if that is so, it's very easy to do. Because what we're going to do is we're going to use the 2 coordinates. We already know this one. It's 0, 1. And we need to find that one, which won't be such a problem. So let's go to the question. And we know that this is going to be 0, 1. And this one must be minus 2 something. And how we find the something is we substitute x equals minus 2 in this equation. So y is equal to minus 6, minus 2, minus 3, minus 1. So it's going to be minus 6 over minus 5, minus 1. And then that's going to be 6/5 minus 1. And if your fractions are good, you know that 6/5 minus 1 is 1/5. If they aren't good, you'll take a common denominator, and you'll go 6 minus 5, which gives you 1/5. So that's the coordinate 1/5. So the best way to get average gradient, okay, is to use our gradient formula using the points. So let's call this x1, y1, x2, y2. So the average gradient would be y2 minus y1 over x2 minus x1. So 1 minus 1/5 is going to be 4/5, and that's going to be positive 2. Now remember, if we're dealing with a fraction divided by a whole number, best approach is to make that a fraction as well by putting it over 1. And then we would say 4/5 times 1/2, because we invert and multiply. Doing that, that goes once, that goes twice, and the answer is going to be 2/5. Okay, now always ask yourself, does my answer make sense? So let's go back and have a look. Does it make sense? If I go back to the graph we had earlier on, would this gradient be positive or negative? Well, certainly you can see it's going uphill, so the gradient would be positive. And yes, 2/5 would be very possible. If it was negative 2/5, I'd know I'd made an error, but I definitely have not done that. So here we have the question. Now the other way to do it is much more difficult, and I'm not going to do it, but I will mention it. The average gradient is given by this formula, the f of x plus h minus the f of x over h. And you'll recognize that from first principles. So now what you would have to do is work with your x's, and you would have to get a thing to the end, but once you had done that, you'd have to say, right, it's between -2 and 0. So you would take x as -2, and your h would be how far you moved from there to there, which would be 2. And if you did that, you would get the answer as well. Right, so that gives you an idea of this question. I think it's quite a nice question. It's got some calculus involved. It's got a little bit of our basic sort of finding x and y intercepts, asymptotes, and sketching. And so it's quite a presentable question to ask in an examination. Right, we're going to go to ad break, and I'll see you after that for the next question. Hi, welcome back. We're now going to try question 2, and what I like about this question is it mixes the parabola with the exponential. Many years ago, it used to be very traditional. They used to always keep the parabola with a straight line, but it seems to be a trend now to move between the graphs, which is really nice. Okay, let's have a look at it. It's adapted from November 2011, paper 1, question 6. The graphs of f of x equals 2 to the x minus 8 and g of x equals ax squared plus bx plus c are sketched below. Oh, goody. Why are they doing that? Well, obviously they're going to ask me at some stage to actually find that equation. I'm pretty sure of it. Otherwise, they wouldn't have given it to me like that. Okay, b and c, and they give me the coordinates of c. C is 4.5, are the y-intercepts of the graph of f and g respectively. So in other words, the b is for f and the c is for g. So the parabola's y-intercept is that. The two graphs intersect at A, which is the turning point of the graph of G, and the x-intercept of the graphs of F and G. So they're telling me and, so it's both of those things. Right, so let's have a look at the picture. So they tell me this is 0, 4.5. They tell me this is the turning point and the x-intercepts of the two graphs, which makes perfect sense. They also told me the equation of the graph, which I want to just jot down. It's y equals 2 to the x minus 8. And they asked me to determine the coordinates of A and B. Now, if I've got the equation of the exponential, both A and B belong to the exponential, so I have no problem to find those points. In fact, what they're asking me for is the x-intercept and the y-intercept of that graph. So let's do it. So if we take y equals 2 to the x minus 8, and let's start with the x-intercept. To find an x-intercept, we let y equal 0. So 0 is equal to 2 to the x minus 8, which means 8 equals 2 to the x. Once again, you'll notice I've avoided bringing a negative in front of my exponent. So I like to write it the other way. So maths is wonderful. You can read from left to right or right to left. Doesn't make a difference. So 2 to the x is equal to 2 cubed. Therefore, x is equal to 3. So we've got that. So we have coordinate 3, 0. Right, now let's go for the y-intercept. Let's change colors so it all stands out nicely. So the y-intercept, we're going to let x equal 0. So y is equal to 2 to the 0 minus 8. What do we know about anything raised to the power 0? It's equal to 1. And so y is equal to minus 7. So we have coordinate 0, negative 7. Have we answered the question? It said determine the coordinates of A and B. We have. We haven't told them which one's A and which one's B. So this one's the B and this one's the A. Now we've answered the question. Because obviously if I just put the coordinates but I didn't say which one was A and which one was B, a sticky examiner or marker could take off some marks for that and say, well, you didn't stipulate. But hopefully they're kinder than that. I think they are actually. But anyhow, the good news is you do label it, you have answered the question, all is good. So right, let's go to the next part of this question. So remember what I said to you, we always try and put on the drawing what we know. Just going to go back here and remind myself so I don't give you the wrong points. 3 and negative 7. 3 and negative 7. Okay, so this is 0, negative 7, and this is 3, 0. Okay, now it's always good to fill in on your drawing the things you find because usually it builds. So once you've answered the first question, whatever you found out in the first question helps you in the next question, and so on and so forth. What happens if you get into an exam and you can't do the first question? What you do is you take a very educated guess. You look at the picture and you say, maybe you won't say minus 7, so you say it's 0 minus 6. And over here, say you say it's 2, 0. At least you can carry on with the question. So what you would do is you'd say, assuming A to B, assuming B to B, and you'd carry on going. Because in the end, you would get method marks for the next question, which is better than getting nothing. Hopefully, the question will say, show that. But anyhow, just in case they don't, let's do that. Now it says, write down the equation of the asymptote of the graph of f. Now, f was the exponential, and I'm just reminding myself what it said. It's y equals 2 to the x minus 8. Now, what you're going to remember is the format of this is y equals a to the x minus p plus q. Okay, now the good news is here you won't ever have a horizontal asymptote on an exponent, but you won't always never have a vertical asymptote, but you will have a horizontal, and there it is. So y equal to q. So in this case, in the light of the equation, we know that the asymptote is y equals minus 8. Have we answered the question? The question was write down the equation of the asymptote, and we have answered that. We've given the equation as y equals minus 8. So on the drawing, what I'm saying to you is there is an asymptote along here cutting through minus 8. Right, let's see what the next question asks. So it's 0, minus 7, 3, 0, and this is y equals minus 8. Right, let's see what it says. Determine the equation of h of x if h of x is equal to f of 2x plus 8. Well, that's not going to be hard. We know what f of x is. F of x is 2 to the x minus 8. So what would the f of 2x be? Well, what it would be is we would go along and wherever there's an x, we would put 2x. So we'd say it's 2 to the 2x minus 8. Now, we can leave it like that. But remember, they also said to you we must add 8, but let's worry about that just now. Another way to deal with it is to think it's 2 squared all to the x minus 8, which means it's 4 to the x minus 8. So that would be the f of 2x. Right, but assuming you didn't do that, assuming you're still working with this format, 2 to the 2x minus 8, what is h of x? H of x is the f of 2x plus 8. Oops, I nearly made a mistake here. I've got the 8 in the sky. The 8 should be down below. Right, so the h of x will equal, in place of our f of 2x, we're going to go 2 to the 2x minus 8, but we've still got our plus 8 over here, which is very good news, because we now have 2 to the 2x, those guys become 0. So we've got that, and if we wanted to, we could write it as 4 to the x, and quite honestly, I think it is easier to think of it like that, although nothing wrong with that top one. It's also fine. Right, so we've got the equation of h of x. So let's go over here and let's fill in what we need to know. So we know that h of x is 4 to the x, or if you like, it's 2 to the 2x. And they didn't tell you any particular form, so you're welcome to use either one. Now it says determine the equation of h to the minus 1. Now that's why I said to you it was easier to work with this one. Because what happens with an inverse? Well, in actual fact, we're looking at h, which is the equation y equals 4 to the x. Now, an inverse is the reflection along the line y equals x. In other words, we swap the x and y around. So if I go back to this over here, to get to h to the minus 1, I would go x equals 4 to the y. But they've told me I must write it in that format. So what I have to do now is change it so y is the subject of the formula. Now hopefully you know that an exponential and a log graph are inverses of each other. So in actual fact, we're going to change this from an exponent into a logarithm. So we're going to say y equals, and it's going to be log, the base is 4 and the number is x. There we have it. And now that is written in the format they wanted for h to the minus 1. So that's absolutely fine like that. I'd like to just spend a few seconds here mentioning, if you're inclined to get confused, take your calculator and work out the log of 100. The answer will be 2. On your calculator, it'll tell you that. The base of the log will be 10 if we've written nothing. So what do we know? We know that 10 squared is 100. Now, using a similar process, we know we've got 4 to the y equals x. So we're going to reverse this. Well, the 10 was equivalent to the 4. The x would go, well, this exponent would be the y, so it would be there, and the x would be the equivalent to the 100, so it would go in over here. So that's a way, if you ever get stuck on how to change from an exponent to a log, that's how you would do it. Now, you do agree with me, I'm sure, that if I was working with y equals 2 to the 2x, it would have been a little bit more difficult, because I would have now made it for the h to the minus 1, x equals 2 to the y. Now, when you come to change the format, the 2y would sort of be in the way. So you would have to say, well, that means that 2y equals log to the base 2 of x, which means y is equal to a half log to the base 2 of x. Now, if you had done that, they would be the same answer, believe it or not. Now, I'm going to show you why it's the same answer. If you've got log to the base 4 of x, and you're using your change of base law, it would be log x over log 4. The log of 4 would be equivalent to the log of 2 squared. And from my log laws, this would come in front. Now, quite honestly, I think this is beyond you in terms of what you're required to know. So that would become a half of log to the base 2 of x, which is exactly what we got. So believe it or not, it is the same, that one or that one, but I would advise you to go that way. That way you're pretty safe and you're not going to go wrong. Right, let's see what else this question has in store for us. Right, so we've established these points. It was 0, -7. I think that was 3, 0. Okay, now it says, write down the equation of P. P is the reflection of the inverse of H. Well, the inverse of H, remember, was log to the base 4 of x. Or if you like, it was written y equals log to the base 4 of x. Now, We want an equation of P. It's a reflection in the x-axis. Now, the best way, if you want to remember it off by heart, it's fine. But it's not hard to think about it. If you take a little axis, and you plot a point, say, 4, 2. And you say, I want to reflect it in the x-axis. Now, if I do, the x will stay 4, but the y will change to -2. So we know that to reflect in the x-axis, we change the sign of y. So P then will be minus y equals log to the base 4 of x. And of course, that will become y equals minus log to the base 4 of x. Now, there is another way to write this. Again, it's not necessary. You could write it as log to the base 1/4 of x. That and that are equivalent forms of the equation. But quite honestly, within this question, I think you'd be fine leaving it at the top one. But it's up to you, and you can prove it by using that change of base rule again if you want to show yourself it's true. Right, let's see what the next part of the question asked for. It says the two graphs intersected A, which is the turning point of the graph. That's what they told me. And now they ask me a very, very interesting question. They start talking about G. Up to now, G's just been sitting there. Absolutely nothing happening with G. We do know that that's 3, 0, and we know that that is the point 0, negative, 0, 4.5. Now, the first thing we have to do is find the equation of G, because they're using our G of X notation there. Plus, what's interesting about the question is they are going to bring sigma notation in, which is a lovely opportunity for us to just recap that with you. Right, so let's have a look what we'll do. First thing we do is we want to find the equation of the parabola. What do we know? We know the turning point and one other point. So the best approach is to use this formula. And this would be your P and your Q. So y is equal to A, x minus 3 all squared plus 0. And of course, the plus 0 is not important. We've got this. Now, how do we solve for our A? We take our other point, which is our C value, and we sub it in. So C is the coordinate 0, 4.5. I like to work with fractions rather than decimals. Doesn't matter, though. Right, so once we do that, we're going to say y. Well, in fact, I'm not going to do that. I'm going to substitute straight in. That's your x and that's your y. So let's go 4, 5 equals A, 0 minus 3 all squared. So it's 4, 5 equals A, and that's minus 3 squared, which is 9. So A is equal to 4, 5 over 9, which, thanks to good planning on their question, works out very nicely to be a half. So A is equal to a half. So we have equation y equals a half x minus 3 all squared. Now it's up to you at this stage. You can go and work this out by multiplying out, but I don't think it'll make your question any easier. Now what are they telling me? They're saying to me, sum from k equals 0 to 3, the g of k. Now what we have here is the g of x. So the g of k won't be a huge deal. G of k will be a half k minus 3 all squared. Now what does this mean? That sign, as I said to you, means sum from this value to this value. So in other words, we're going to put in k equals 0, k equals 1, k equals 2, k equals 3, and that's where we're going to stop. So we're going to say the g of 0 would be a half of 0 minus 3 squared, which is a half of 9, which is 4, 5. Okay, the g of 1 would be a half of 1 minus 3 all squared, which is a half, and that's going to be negative 2 squared, which is 4. Half of 4 is 2. The g of 2 is going to be a half of 2 minus 3 all squared, which is going to be a half minus 1 squared, which is a half of 1, which is a half. And the g of 3 is going to be a half of 3 minus 3 all squared, which of course is going to be 0. So if I'm working out the sum from k equals 0 to 3 of g of k, the answer would be 4, 5 plus 2 plus 0, 5 plus 0, which would have given me 7. So that's easy enough, just time consuming, but not bad. So the answer of that is 7. Now from that, I must subtract this. So let's get ourselves another color. It's again g of k, but this time it tells me k starts at 4 and ends at 5. So that's not too bad. So I need to just work out 4 and 5. So the g of 4 is going to be a half of 4 minus 3 squared, which is equal to a half of 1 squared. So it's going to be a half. And the g of 5 is equal to a half of 5 minus 3 squared, which is a half of 2 squared. 2 squared is 4, and a half of 4 is 2. So before we go there, let's just add in an extra bit here. The sum from k equals 4 to 5 of g of k would be a half plus 2. So it would be 2, 5. Right, so we go back to the question. This is 2, 5. So if this is 7 minus 2, 5, is it going to be a problem? So we know that the sum from k equals 0 to 3 of g of k, subtract the sum from k equals 4 to 5 of g of k, is going to equal 7 minus 2, 5, and that's going to give me 4, 5. And that's what we would do. So it's actually quite an easy question. Just time consuming. That's always the negative side. But it was a good opportunity to remind ourselves. Now, you must just be careful. And before we go any further, I want to just say to you that maths is not in little compartments. Everything melds together. So yeah, you've got some sigma notation, which is normally associated with sequences and series, appearing in the middle of graphs. There's nothing to worry about. The principle you've been taught in sequences and series will carry on and be a principle within your graphs. Right, so I think that brings us to the end of this question. So I think it's time for us to go to an ad break. And then after the ad break, we will go on with the next question. Hopefully this has given you something to think about while we have our break. See you later. Hi, welcome back. We are about to now tackle our question 3. And before we started, I just want to tell you it was adapted from February-March 2011, paper 1, question 7. So it says consider. Now, I always love the words we use in maths. We say consider. But basically what they mean is this is the graph we're going to work with. It says, is f an increasing or a decreasing function? Give a reason for your answer. Okay, now how I make sense of this is if we're thinking of the graphs, and I think I've managed to successfully demark my pen. If this was y equals 2 to the x, do you agree with me that this is, as your x's are getting bigger, your y's are getting bigger? Or another way to look at it is the gradient of this thing is positive. So this would be increasing. However, if I went and I drew y equals a half to the x, it would now look like that. So now, as my x's are getting bigger, my y's are getting smaller. Or another way of looking at it is the gradient is negative, so it is decreasing. Now, we can just learn the fact that if we have a graph y equals a to the x, and a is greater than 1, it is increasing. And if a lies between 0 and 1, it is decreasing. So what do we know? We know we're looking at the graph of y equals a third to the x. A third lies between 0 and 1, therefore decreasing. That would be my reason. I have qualified that my A value has decided for me where I must be. All right, so in the light of that, that's the question answered. You could also talk about gradient or draw a little mini sketch. I think you are going to end up sketching it anyhow. So let's see what the next question says. It says, now determine f to the minus 1 of x in the form y equals. Now this is very similar to the previous question, except this time they've given me a fraction. It doesn't make a difference. So what do I know? I know that f was the graph of y equals 1/3 to the x. So if I'm going to do the inverse, f to the minus 1, I know that I must swap the x and the y around because it's the reflection in the line y equals x. Now the moment I do that, if I want it in y form, I have to change it to a log. So you can see these are two different exam papers. Both of them have required you to move from an exponential form to a log form. They could have asked you to go from log to exponential too. So I did show you how to avoid getting stuck on that. So the exponent is y equals log to the base 1/3 of x, and that would give me the equation f to the minus 1. All right, so nice and easy so far, nothing really hectic. Right, the next one says, write down the equation of the asymptote of f of x minus 5. Ah, interesting. So now they're saying, instead of working with y equals f of x, work with y equals f of x minus 5. So y is equal to 1/3 to the x minus 5. This is where, and it's only 1 mark, so they expect you to do quite quickly. Your understanding of graphs is quite important, because if I drew this one, this third to the x, it would look like that, and the asymptote would be at y equals 0, or the x-axis. Now, if I'm shifting the graph down 5, the asymptote would be at y equals minus 5. So that's one way I think you can do it relatively easy, just knowing your theory. Right, let's see what 3.4 says. Describe the transformation from f to g. Now, this is a lovely, lovely little question. Okay, they want to know from f to g. So let's have a look. F of x, how does it look? Well, it's a decreasing function, and it's my original, so I know it'll cut through 1. Let's put my x-axis in, the origin, and the y-axis, just a little rough sketch. How would this one look? Well, this one would be the inverse of this one. In other words, it would reflect around the line y equals x, so it would look like this. This would be y equals log to the base 3 of x. So, if that's the case, there are actually two things that have got to happen. The first thing is it's got to reflect about the y-axis, and then it's got to reflect about the line y equals x. So we need to get this movement first of all, to change it to y equals 3 to the x, and then we would use this to get there. So let's describe the transformation. So what we're saying is f of x is reflected in the y-axis, to give us, let's call it g of x. No, that g of x is what we've got there, so let's call it h of x. And h of x would equal 3 to the x. H of x is reflected in the line y equals x. And that gives us g of x, which is log to the base 3 of x. So that's how I would describe it. I think it must be worth 2 marks because you had to do 2 different things to get there. Yes, it is 2 marks. So that would give you 1, 2 over there. Very, very nice question, testing your ability to reflect and use your knowledge of inverses. Right. Let's go to question 4. I'm going to try to squeeze a little bit of question 4 out. I can't do a lot of it, but I'll do whatever I can. Right, it says there, consider the function f of x equals 4 to the minus x minus 2. Now, just before we go anywhere here, we could write this as 4 to the minus 1 to the x minus 2, which in turn would be written as 1/4 to the x minus 2. So really what we're getting here is a need to understand the different ways of writing exponents. That you could write it as a whole base and put a negative in and effectively have a fractional base. Now it says calculate the coordinates of the intercepts of f with the axes. Okay, well that's not a problem. It's our good usual question where we want the x-intercept and the y-intercept. I personally prefer to work with it in this format. It doesn't really matter, so maybe I should work with the original. So let's work with the original. F of x is equal to 4 to the minus x minus 2. For an x-intercept, we let y equal 0. So 0 is equal to 4 to the minus x minus 2. So 2 is equal to 4 to the minus x. And we know that in order to solve this, we have to have the bases the same. So 2 is equal to 2 squared to the minus x. So 2 equals 2 to the minus 2x. Now we know at this stage the base is the same, so we can equate the exponents. So 1 is equal to minus 2x, and so x is equal to minus a half. So we have a coordinate minus a half, 0. Right, let's change our pen, and let's now have a look at how we find the y-intercept. So for the y-intercept, we let x equal 0. Now this is going to be a little bit easier because y is going to equal 4 to the minus 0 minus 2, and we all know that anything to the 0 is going to equal 1. So we're going to get 1 minus 2, which means y is minus 1, which means we have a coordinate 0, negative 1. So have we answered the question? It said calculate the coordinates of the intercepts of f with the axis. Yes, we've done it. Have we written it as a coordinate? Yes, we have. So that's all good. We're ready to go on to the next part of the question. I just want to pop those down in case we need them. Just make sure I'm not incorrect. Yeah, that's right. The trouble with these questions, if you transcribe incorrectly, you can end up with a bit of a nightmare on your hands. Okay, so now it says write down the equation of the asymptote of f. But by now, you're experts. We've done a few of these. We know that the asymptote is a horizontal one, which is y equals this part, the minus 2. Okay, nice and easy, 1 mark in the bag. So far it's flowing nicely. And now this is the part I knew was coming, but I just didn't know when. Let's just check I've given them correctly. And then the asymptote is y equals minus 2. Right, so now we're ready to actually draw it. It says sketch the graph of f. Okay, sketch the graph of f below. Okay, the on is not supposed to be there. Sorry, I didn't see that till now. So let's put in an axis, and I'm going to try and be good and put in a nice axis, straight lines for a change. Okay, and we are going to draw it, so let's just get hold of a pen. We know that we have an asymptote at minus 2, so let's put it in. Here it is. We have minus a half, 0. There's a 1, so let's make that minus a half. And we have 0, negative 1, which is here. We know it's exponential. Oh, that was a bad draw, so let me just undo that and try again. This time trying to go straight. Not much better. Sorry, I'm going to have one more try, and if I don't get it right, I'm going to live with it. Okay, there it is. The graph continues. Getting closer and closer to my asymptote. I think that's clear enough. It's fine. That's your x-axis, that's your y-axis, that's your origin. Right, so sketching the graph is no problem. Right, the next question says, write down the equation of g. If g is the graph of f shifted 2 units upwards. So if it's moved 2 units upwards, it's moving vertically up 2, which means the q value gains 2. So it's not going to be a problem to do g of x will be 4 to the minus x minus 2 plus 2, because we're going to shift it up 2. So the equation is going to be 4 to the minus x. All right, nice and straightforward, not really any problem with that. Let's see what they ask next. Now they say solve for x if f of x equals 3. You need not simplify your answer. Okay, so let's see what they mean. Obviously, it's going to be some kind of interesting snippet here, and that's why they need to do it. So f of x is equal to 4 to the minus x minus 2, but they tell me that f of x equals 3. So 3 equals 4 to the minus x minus 2. Now, if we do that, we're going to move the 2 over, so we're going to get 5 equals 4 to the minus x. Problem, we cannot use exponents here because our bases are not the same, nor can they be the same. In other words, I can't make them both powers of 2 or both powers of 3. There's no way I can do that. So the only option I have is to work with logs. They said I need not simplify it, so that means I can go straight to this. I can say minus x equals log to the base 4 of 5. And if I want to solve for x, x is equal to minus log to the base 4 of 5, which is fine. And they said you need not simplify your answer, so you can leave it there. If they wanted an answer, you go to your calculator and you put it in your calculator and give them the answer. That's not a problem. Now, remember what I said to you is if we had been working with this format, perhaps it would have been a little bit neater. We would have gone x equals log to the base 1/4 of 5. But they are exactly the same answer, and the person would have to give you either mark because they didn't stipulate anything really about how your base had to look or what your graph, your actual thing had to be. Right, I think that brings us to the end of this. I did a quick run on this question because I tried my best to finish it. And as you can see, we've covered quite a wide variety of things. The important thing is to stay focused and not to let any unusual or different questions throw you in any way. So all the best for your exams and for your work, and we look forward to seeing you next time. Keep well.